All right, I'm excited for this video. It's gonna be a fun one, and I don't mean that in like the diabolical math professor. Hey, you guys are gonna have fun. I think it's actually gonna be funny and fun. So we're gonna start with a little recollection. So if we have some function y, the derivative of y, we call it y prime, right? And then we can have the second derivative. Right? Higher order derivatives, y triple prime, right? And then after that, we just start putting the number in parentheses. Remember this. I think it'd be cool if we did it like we just went full on Roman numerals. Like then we'd have the fourth derivative, but it doesn't work that way. Nobody asked me what I thought 200 years ago when they were doing this stuff. 150 years ago. I don't actually remember when Newton was alive. Anyway, I'm no historian. We're going to start with an example. This is a good example. This is example number 5. Let's see. For y equals the sine of x, find the 20th derivative. Jason, you can't be serious. You want us to take the derivative 20 times? Yes, I do. I want you to take the derivative 20. It's like when you got a lot of things to do, you got a lot of work. You just, no use whining about it. Get to work. All right, no complaining here. All right, 20. This is a good derivative. Let's leave room for 20 derivatives, guys. Let's go. Y prime is, well, the derivative of sine of x is cosine of x. The second derivative is just the derivative of the first derivative, which is negative sine of x. The third derivative is the derivative of the second derivative. What's the derivative of negative sine? Well, the negative comes out in front. It's just, what is the derivative of sine of x? Derivative of sine of x is cosine of x. Okay, well, that brings us to the fourth derivative. The negative comes out in front. Derivative of cosine is negative sine. So it turns it into a positive. Wait just a darn minute. Jason, I pulled a fast one on you guys. Why am I laughing? Because we're exactly where we started. The fourth derivative is the same as the original function. So you can imagine that the fifth derivative, well, I mean, the fifth derivative has got to be this. Sixth is going to be that. Seventh is going to be that. Eighth is going to be that. We don't have to do these at all. We just have to figure out which one we are. Well, if we count by 4, right? Every fourth derivative, 4th derivative, 8th derivative, 12th derivative, 16th derivative, 20th derivative are all going to be the same. All right. So the 20th derivative is just the original function. And you could do the derivative 20 times, but you don't have to. Okay. Now, if I made you do this problem for like cosecant, then you'd have a bit more of a headache. All right. So that's just a quick reminder of higher order derivatives. And I'm not really going to be making you do a lot of these. I'm not going to ask you like, oh, what's the 132nd derivative? Like you can, and it's kind of fun, but it's not that useful. But this is just a quick, fun little way to tie some topics together. I hope you got a little angry. I hope I tricked you. Hope I fooled you. All right, let's go. Let's deal with another particle again. This is a natural way to abbreviate particle, right? Particle moves with position function. Position function s of t equals 2 minus the sine of t. And I want you to find a couple things. Find the velocity after pi over 4 units of time. Again, velocity is just the derivative of position. The velocity is just s prime of t, just negative cosine of t, right? Derivative of 2, that's a constant, it's 0. Derivative of sine is cosine, and it's being subtracted. So specifically, the velocity after pi over 4 units of time is just negative cosine of pi over 4. Again, remember those reference triangles. Pi over 4 is 45 degrees. And that's this triangle. The cosine's 1 over root 2. I really don't care much about rationalizing denominators in this sense. But if you wanted to, you could. That's the velocity. So it is, negative. It's moving backwards. It's moving to the left. Negative velocity means, negative just means directions for velocity and position and acceleration. So I just heard a sound and I couldn't tell whether it came from my computer or my stomach. How many sounds can you think of that you wouldn't be able to know between the two of those things? Find the acceleration after pi over 4 units of time. Well, again, acceleration is just the derivative of the velocity. Acceleration is just how is your speed, velocity changing. Speed is not technically the same as velocity. Speed is the absolute value of velocity. Speed doesn't have direction. So a of t is just v prime. So let's just take the derivative of that velocity equation. Derivative of negative cosine is positive sine. Because derivative of cosine is negative sine, so we have two negatives. Now we're at positive sine of t. So specifically the acceleration. And we like to have units, but this problem didn't give us units, so we can't give our units, and we can't say our velocity is like negative 1 over root 2 meters per second or something like that. So similarly, this is going to be 1 over root 2. The sine of pi over 4 is 1 over the square root of 2. So it's moving backwards, but it has positive acceleration. If the acceleration is the same sign as the velocity, it's speeding up. If it's an opposite sign of the velocity, then it's slowing down. So we're going backwards, but we are slowing down. If we think of that positive acceleration as meaning the velocity is becoming a more positive number, less negative, we're moving backwards, but then we're, slowly moving less backwards. So slowly moving less backwards, and then we start moving forwards, and then we accelerate, and then go. All right. 2-part C. Is it speeding up or slowing down? Well, I already answered that. I got ahead of myself. Basically every problem with multiple parts, I like to connect the topics, so I just start talking. I'm not even going to write the answer. I'm just underlining the right one. All right. So you might say, Jason, are we done with this video? And the answer is yes. So good luck. You should be able to do the entire homework assignment now. Bye-bye.